let's start at the beginning then. Containers did have and does have still a bunch of hype. So why containers in the first place, Dave?
Well, I like telling people about my first container experience, which was like 2014, Open Daylight again. The problem that we were facing was we were developing something built on top of Open vSwitch, and because Linux distributions are very famous for having great packaging, fantastic packaging. If the sarcasm's not coming off, I'm being incredibly sarcastic right now. What we were finding was that there were at least 10 different versions of Open vSwitch at any one time across all of these different distros. So, like, what do you even do with that? How do you test that? And I went and spoke to the nice folks that were running the CI at Open Daylight and said, hey, can I like have 10 maybe machines with like Open vSwitch running on there, and could you like just reset them after every time that we've run our tests for us? And they kind of gave me this look, and we're like, that sounds like a lot of work, Dave. No, just no. Go figure it out for yourself. I was like, damn. And that's when I discovered Docker, and that's when I figured out that I could put Open vSwitch, the user space stuff, inside a container.
Yep.
I could have Docker on one machine. I could spin up 10 different versions of Open vSwitch. I had full control over what was running and when, and like this just opened all of the doors of possibility. You didn't need to be an expert to install OVS somewhere anymore. It was as simple as run a command, and here is the version that you need. And I think it's that type of simplicity that really has made Docker take off. Like it killed two things, right? It killed off you need to go and find a guide written by somebody on the internet to install this piece of Linux software because it's already prepackaged for you in a container. So that was great because as a developer, I can try out that new database without having to waste an afternoon figuring out just how to get the thing running on a server somewhere.
Yeah.
And
there's a meme that speaks to that, Dave. I saw it on Twitter the other day. Johnny Depp is speaking to a tearful child. The child is looking up at Johnny Depp and he's going, but it worked on my machine. And the next panel is Johnny Depp looking down at the kid going, then we'll ship your machine. And thus Docker was born.
Right, and that's so true. Because that was the other thing that it helped kill off as well, was that kind of dependency hell that we were getting ourselves into. And that works on my machine thing. So I guess the typical thing that I would see as a developer is, say we were using Java, and then Java 1.9 comes out. And we're like, yeah, 1.9's got this really cool thing and this really cool feature, and we want that. And then you go and have that awkward conversation with the ops team about, hey, we're thinking of upgrading Java to 1.9. It's not been packaged yet by the distros. We're expecting like maybe a package in 12 months. But how would you feel about packaging that and kind of running that for us so that we can use this cool new feature, which is going to make our lives easier? And that wasn't a fun conversation.
No.
No.
Can't imagine. I think your situation where you were testing a bunch of different versions of Open vSwitch, that makes a lot of sense from a local development standpoint, but I can't imagine that you would then want to use those same containers to run Open vSwitch in production. You would still want to deploy that at the base OS level. Is that right? Or would you actually want to run Open vSwitch in a container on a server?
So you can do, and that was one of the cool things that we very quickly realized is that containers, despite being cool containers, are kind of leaky. So you could, in fact, with the necessary privileges, run a container on a host. It would then have the ability to load in the Open vSwitch kernel module if there wasn't one pre-existing, and Open vSwitch could run in the context of this container. With it being OVS, you can expose, the Open vSwitch socket to other things because everything in Unix is a file, so you can just bi-mount it somewhere else. We had OVSDB running, so you can expose the TCP port and let other things talk to it. So it's absolutely plausible to run in a container. But yeah, sure, from a sensible operation standpoint, if it's going to be running on the host, yeah, sure, like install it on there. You don't have to deal with you don't have to deal with containers for that. You just have to wait for that lag, right? So
Right.
let's say, Ben and Justin, oh, big security fix, like we've pushed this thing out. Oh, there's this great new performance feature in OVS 2.2, and all the distros are like, yeah, we're still on 1.8. We'll get you that new version in like, I don't know, like 12, 24 months. And that was a big problem. Things were moving too slowly, I think, for a lot of things, especially in the
Sure.
early days of OpenFlow. Like every point version of Open vSwitch was like a new point version of OpenFlow, and there were some massive differences between what you could do in 1.0 and 1.3. Well, like, give me multiple tables already on all the devices everywhere, so we can do cool stuff instead of just being stuck with one table. So
Right.
yeah, that lag became really difficult to kind of get past. So yeah, circumventing the packaging. In the distros was one way, or I guess hosting your own packages, but then you have to be supporting those, and that's
Yeah.
not work, right?
So it sounds like containers are just a perfect solution with no problems whatsoever, and everyone wants to just use them. Or would you say, if that's why containers, why not containers? What are some of the downsides?
So I think so. One of the problems that we had in the very early days of containers was the size of the things, and that
Hmm.
everybody's. I guess one of the maybe popular myths about containers is that containers are always smaller than virtual machines. And I think in large part that was because when we were building virtual machines, we weren't exactly building them intelligently with let's try and make this really small as the primary goal. It was let's just make it stable. Let's just
Right.
install from the CD like we normally would on a server. Um, yeah. So what we were finding was that containers were huge. Like in the early days, like Ubuntu was maybe 2 or 3 gigabytes, and then you would, layer yourself on top of that as well. By the time that you've added, a Java runtime and Tomcat, and then something else, like your container size is pretty big.
Hmm.
So that definitely in the early days was a drawback. Um, what we're finding now is that there are ways of reducing that size. A lot of the distros, the base images have got a lot smaller. We've had things like Alpine Linux appear, which is super small. It's around about 5 megabytes, I think, at last look. The entire operating system is five
Yeah,
megabytes.
I think that's about right.
So you've got some mileage there for sure. But then I guess the interesting thing here is that what we've created with containers is now the sprawl of mini operating systems everywhere, because all of these things that get deployed plausibly need patching, they need maintenance. If there's a security vulnerability that appears in a Linux distro, which is at the base of your container stack, then suddenly you've got a whole lot of work to do, like building up new containers and then getting rid of your old ones and replacing and making sure that you've kind of patched in place. And whereas that may have been one distro before, now you've got 5 or 6 or 7
Hmm.
out in
Yeah.
circulation.
You're arguing you got a lot more touch points now, things to be maintaining on the operations side of the house if you have a explosion of containers.
Right. So
Yeah.
I've seen what's interesting is that we've created all of these problems. Like we've literally created an entire space. Containers appeared, created a whole new bunch of problems, and then a whole new bunch of companies came out with solutions to these problems. So we've got like software lifecycle management systems now based around containers that are able to tell you, oh, look, there's a security vulnerability in this. It's going to affect these containers. You've got them running over here. You've got them running over here. Like they're trying to make that whole process easier. But yeah, it's interesting, right? It's definitely created a few more problems than I think I was expecting.
Well, created a few more problems that are worthwhile, or a few more problems that are like, if we thought this through, we just wouldn't have gone down this container road to begin with.
Um, yeah, that's a really good question. So I think one of the things that I've been wrestling with recently is complexity. That there seems to be in my mind, obviously IT is complex. It's never going to be simple to the point of being able to do everything with no code. Like I'm not advocating for that, but I feel like there's something in the middle. There's like a middle path, which is where we're trying to make things easier for everybody with some understandable complexity. what I feel that we've been doing, maybe for the longest time, probably as far back as OpenStack, is that we keep on layering abstractions. We're just like, oh, well, this problem is hard, so let's put in another layer of abstraction to then solve this. And then we're like, well, containers are hard. Let's put on another layer of abstraction and call it serverless, and then we'll just deal with the primitives up here, and we don't need to worry about what's going on down here. And I do think that maybe some of the stuff that we've done with containers has kind of added to that. We added this layer of abstraction, and then we've created these new problems, and then now we're just looking at abstracting further rather than trying to peel back some of the layers of the onion and being like, well, maybe there are arguments for being closer to the metal in the first place. Let's reduce the layers of abstraction that we've got and stick with something like virtual machines, say.